So let's take a look at a few examples. I'm going to pause the video and I want to see if you can decipher what is the domain of these three functions and see if you can do it in interval notation. So looking at our first example, you will note that it is a polynomial function. More specifically, it is a quadratic polynomial function. For polynomial functions, you always have all real numbers as the domain. So in this case, we would write it out as negative infinity to infinity, as we did, as you see, also on the functions categories handout. Looking at our second example, we obviously have a rational function in this case. So we have to determine what values are not included in the set of this function or for the domain of this function. What I have to do in this case is factorize the denominator, giving me 3x over, and I need two numbers that multiply to -6, but add up to -1. That gives me x minus 3 and x plus 2. So what we have is a scenario where x cannot equal 3 and x cannot equal -2. The interval notation for that domain looks like this. So I have all numbers that are negative up until -2. Notice the rounded parentheses because 2 is not included in the set. Or all values between -2 and 3 or all numbers from 3 till infinity. Let's take a look at this function on our graphing calculator just to get a little bit more understanding and have a visual to accompany this. So we're here at our graphing calculator, and I've already cleared my calculator, making sure that there's nothing here, and I'm going to where I enter my function. So remember that my function was, the numerator had 3x, and it is divided by, and notice that I'm opening up a parentheses, and I'm going to write the original or the expanded or the standard form of the quadratic, which was x squared minus x minus 6. Close your parentheses. So that is our function. And I will hit enter. Now, remember, we found that the function did not exist when x equaled -2 and when x equaled -3. So let's take a look at our graph. So notice that if you look at the function when x equals -2, the function does not exist there. And I can even graph the function if, well, in this case, I'm unable to graph the function x equals -2. But you can see that the function does not exist at -2. You can also see at 3, the function does not exist. So we are unable to, or visually, you can see that the way that the function looks graphically supports our interval notation. I can even go so far as to look also at the table of values. I hit second graph and it takes me to the table of values. You will notice if I go to -2, there's an error because the function does not exist there. I also go to 3, once again, an error because the function does not exist there. So you can see how your graphing calculator can help you to get a visual representation of the function and determine its domain. Taking a look at our third example here, we have a function h of x equaling the root of x minus 1. In this case, the only restriction is that I cannot have a negative value underneath the radical. So all the values have to be greater than 1. So in interval notation, 1 can be included. So I can use a rectangular parentheses, and it goes until infinity. And I use a rounded parentheses to represent that.